Oh, perfect. So, hey everyone, I am Brad Itzelberger, Business Development Manager for our municipal product lines. I'm located in Charlotte, North Carolina, and I'll kick it over to you, Steve.
I am Steve Mosley. I am the product manager at Industrial Flow Solutions. I am based in Connecticut, probably about half an hour from our factory here in New Haven. Industrial Flow Solutions specializes in intelligent pumping solutions. We offer a variety of submersible pumps, direct inline pumping systems, and complete control packages for the municipal, industrial, and commercial spaces. Our headquarters is here in New Haven, Connecticut. We also have manufacturing for the European market in Monselice, Italy, manufacturing submersible and OverWatch direct inline pumping systems. And our primary brands that we go to market under are BJM pumps, Stancor, Drano pumps in Europe, OverWatch, Oilminder, and D-Ragger.
Awesome. Thanks, Steve. So today we'll be talking about one of our brands, which is branded as the Overwatch, and we manufacture this product up there in New Haven, Connecticut. The premise of this is to educate you guys, and it's about eliminating a wet well is what this technology does. So it's a smart technology that lifts influent directly from the point of entry.
So in order to discuss the Overwatch, we need to go through and discuss wet wells in general. Wet wells and pump stations are critical components of any wastewater treatment system. The wet well is effectively a tank put in the ground. Typically, you would fill that tank, signal the pump to start with a control panel based on float switch operation, and then that pump will operate at full speed until the tank's minimum level float activates, stops the pump, and then they cycle through again. This process has been around for many decades, and there are some hazardous conditions that come associated with this process for both the personnel and some environment and safety risks that are associated. Some of the typical problems that we have associated with wet well are potential for sanitary sewer overflows and flooding if either a float switch gets stuck or a pump is not operating properly. More commonly, you'll have foul odors that are associated with these. Many of these pump stations are in residential areas or in busy commercial centers where that foul odor may not be something that is desirable. You've got potential for hydrogen sulfide gas, fats, oils, and greases, which can build up in a layer on the top of the wet well, along with floating debris. And all of these can cause damage to the well itself and to the equipment within it. They do require maintenance. You have a significant amount of excavation depth required in order to provide the volume for the wastewater to build up. And there is always the potential for confined space entry issues with these wet wells. One of the primary components we want to talk about is hydrogen sulfide gas. This is a flammable and toxic gas, which is an occupational and environmental hazard. This commonly builds up in wet wells and can cause significant damage to the equipment within it. It does have a rotten egg odor, so it does contribute to the odors that are typically associated with lift stations. And when you have bacteria in these wet wells, it can break down the hydrogen sulfide into a sulfuric acid. And that sulfuric acid causes much of the damage that you'll see on the right-hand side of the slide with corrosion of metallic components, corrosion of the concrete. And if it makes its way up through the conduits into the control panel, you'll see corrosion on the printed circuit boards and electrical components as well. Next topic we want to talk about is the fats, oils, and greases, the fog layer that develops on the top of the wet well. This buildup creates a surface layer on the top of the wet well that can grow up to several feet thick. In that layer, you'll commonly find the float switches or level transducers, and as that fat builds up on those components, it can cause the float switches to fail and not turn on the pumps, which will eventually cause an overflow if not dealt with in an appropriate time frame. It is a health and safety hazard, and it does cause some pretty bad odors in areas where you've got a significant amount of fats and greases that are sitting in that wet well.
I believe we have a poll that Joy is going to introduce here. So for the polling that pops up here, it's with your current systems or wet wells, what have you experienced, if any, of the following? And we have a couple different options. The option A is odor issues. Option B is ragging or clogging issues. Option C is infrastructure or equipment corrosion. And then D is one or more of the above. And then E is none of the above. So we'll give it a couple, maybe about 30 seconds or so, let you guys answer this, and then we will dive into how this technology works. Awesome.
I'm closing the poll now.
Perfect. Thank you, Joy. So to dive into how this technology works and what we're talking about today is this is a direct inline pumping system branded as the OverWatch. And what it does is it eliminates a wet well. So all the issues that Steve just mentioned, you typically have to see them in applications out in the real world. They're not ideal, but they are reality. And this is what this aims to solve. So by eliminating a wet well, you have a lot of good value that gets provided by that. Number one, we'll dive into how this creates safer working conditions. Number two is it drastically reduces maintenance. Number three is how it can save you time and money. And at the end of this presentation, we'll actually go into a couple case studies, 3 different case studies on the municipal side where it saved municipalities time and money. And then number 4, we'll talk about reducing the environmental impact with this technology. And then number 5 is how you can expand that equipment lifespan as well. So this picture right here gives a good overview of what this OverWatch system looks like. This is a packaged solution here. So this includes valves that you do not see in this picture, and it includes a control panel as well. Again, this is all made up in Connecticut. When this technology first got invented, it actually got invented in France. So it's been around the world for over 20 years now. First installation inside the US actually happened probably about 2016 or 2017. So it's been introduced to the US for quite some time. The first municipal application we'll highlight here today was about 6 years ago in Sherman, New York, which is about an hour outside of Buffalo, New York. And that was at an influent pump station. But here domestically, we have about over 250 installs or so. And then if you look over at the global installations with this technology, there's well over 2,500, with a majority of them being over in France and in that Portugal area, since that's where this technology originated from. So going into this, I'll describe some of the components, what their function is, what their importance is, and I'll highlight some of the key fail-safes with this technology. So starting from the right, I'll kind of work my way over and all these call outs, I'll kind of explain what the purpose of them are. So we have a pipe coming in here, whatever diameter pipe that is, coming in your influent is what we usually made up to. We have a stainless steel wall flange that can be supplied, that it's an OEM piece. So that's something that we make and manufacture up in Connecticut as well. That piece is not always needed. It's an optional piece. If your gravity invert is not sticking out, if it's flush or recessed, you don't necessarily need that piece, but it's something we do offer as an option. The main isolation valve, so that is something we provide with our package. Coming down from there is called out the stainless steel liquid level transducer. So the liquid level transducer is going to be replacing those float switches that Steve talked about in a normal wet well application. So that level transducer is reading the upstream pressure in the pipe in the gravity invert. So it's telling the pump when to turn on, when to turn off with the controller. But then what it really wants to do with this technology, it wants to flow pace. So it wants to keep flow going in and going out. It's a booster almost for sewage applications, pretty much. So by doing that, we eliminate a lot of those fats, oils, and grease issues that you typically see in a wet well. So we don't let things come stagnant. There's a PID in the background of the controller that allows this to flow pace and speed up or speed down based on how much incoming flow it's seeing and what the pressure it's reading. So these again are paired with the control panel, and inside the control panel it has VFDs, and that's how it's able to modulate and dial in with that PID. So coming down from there is a stone trap cleanout. That stone trap cleanout has 4 bolts on the back of it. The purpose of that is to protect the integrity of the pump. So if you have something that comes down the collection network that should not be there, we know that things get down the collection network that people aren't supposed to flush, but it happens in real life and they get down there. So that purpose of that is for it to not come up and damage the pump where the volute is. If it's a heavy piece of debris, I think the best example I hear out in the field and what I usually see is a 2x4 or a chunk of concrete, something that's heavy, that's going to be an odd shape. It will sit down in that stone trap cleanout, and it's an inspection port for you to go and to remove that debris if it's a heavy object. The stainless steel body right here is on the left side. You can't see it on the right side too. It's kind of blocked off in this picture, but you can see it in some of these other pictures. That little swan neck right there for our municipal applications will be about 3 inches in diameter for our smallest size, and it will go all the way up to 8 inches for our largest size. So it can vary in range depending on what pump model and what the size of the pump is that you got. So this will pass 3-inch solids that we do as a minimum, especially to meet the standards for municipal applications. But coming up from there, we have our branch isolation valve. So that branch isolation valve, there's one on the left and there's one on the right that is blocked out as well. If you need to isolate it for any reason, we can do that as well with those. There's a motor mounting plate that goes over one of the pump sides if you need to do any operation to it. Coming up from there is the patented dip cut impeller. So this is a really unique impeller that is really cool. You can see this on the left. We'll highlight some of the different impeller options after this, but it has the option to go forward and reverse based on the controls. So when it's going forward, it's going to be pumping like the picture in the top right, and then it's going to flap down and go into reverse and become a shredder. So it's a vortex style impeller. It's going to be very good for passing suspended solids, but if you need to react without sending any human intervention out there, it's going to be able to shred and anything that comes up towards it. So you can see the picture, the animation going forward and backwards. So that's sitting right close coupled to the impeller mounting hub, which we'll get into, and it's a recess style impeller. Coming up there is the motors. So the motors are actually immersible. So these are premium efficiency motors. They're IP67 rated. So that's the ingress protection rating. And the 7 of that IP67 means that it will withstand at least 30 minutes of 1 meter of water pressure above the motor. So that is what's guaranteed by the IP rating. There have been instances out in the field where they have withstood longer than that, but that is the guaranteed rating for immersible for these immersible motors. So they're not intended to run 24/7 submerged, but if there's a situation where they do need to run submerged, they can. Um, the swing check valve is right here above the discharge. That's something we provide as well. There's an optional flow meter that we would provide, and then there's a main isolation valve as well. So a couple things I do want to point out is these things are, you can see them in a few diagrams later, are always usually paired with a sump pump. We have that sump pump that we provide as well. If there's any ancillary or I&I that sneaks into your system, the sump pump will kick on and put that back into your collection network, basically. If there is anything to go on with your transducer, there is failsafe built into it where it runs at a preset frequency mode, and their call out would be whether they have an auto dialer or a SCADA system or however they need to get called out. We can do all that telemetry for them. But the key of the level stainless steel level transducer is if there is a fault, it's going to run at a preset frequency, which is a great failsafe that's built into the system. So normal operating modes, we usually have this. We size it for full redundancy. One side to do all the peak capacity that it can handle and the pressure points that it can handle. If it needs to go into reverse, all the impellers can go forward or reverse. And then the other operating mode it can go in is it will run in a parallel condition if one pump cannot keep up, basically. So if one pump is running at full speed at 60 hertz and it's still building up level on the upstream side, the second pump will turn on automatically and flush out the system as much capacity as it can get out with two pumps running in parallel. So I'll kick this over to Steve to go into more of the components of the OverWatch.
Thank you, Brad. Brad did a great job of explaining the dip cut impeller. That is our patented design, which is capable of pumping and shredding when necessary. That is a vortex style impeller. If you have applications where you don't need the potential for shredding, where it's more of a clear water application or rainwater application, we do have a standard vortex style impeller, which still allows the passage of solids, but doesn't have the full functionality of that dip cut impeller. Vortex impellers are generally very good for passing stringy solids, and because these pumps are handling the solids one at a time while they come down the sewage stream, you typically don't see as much risk of clogging with this as you would with a submersible lift station, where you've got a lot of the solids floating on the top of the wet well. We also offer a high efficiency impeller, as shown on the right-hand side. That is our most efficient hydraulic design and is our standard on the larger units that we offer. We've got a number of different designs on that high efficiency impeller, including the 2-vane that's shown there, as well as a few different 4-vane designs for larger flow rates and some larger heads. Next, we're going to go into the assembly of this hydraulic end. The maintenance on this OverWatch system is very easy. All of the hydraulic components are close coupled to the motor, and you can remove that motor typically with about eight nuts that come off, and you can remove that entire motor from the housing. When we ship the unit, we do include a closing plate, so while you're working on that one motor, you could seal up that open volute and then allow the other pump to operate in its normal capacity while maintaining the second motor. The motor is the motor is mounted to a mounting plate which has a seal leak detection channel. That channel will weep any leakage off to the side away from the system itself. So the motor is still protected and dry in that situation, and it does indicate a leak. We do offer the option to put a leak detector in that channel that would alert the control panel if you do happen to have a leak. Mechanical seals that we use as standard are tungsten carbide, extremely hard faces, suitable for some pretty heavy duty installations. And as we continue going down, the impeller mounting hub is what holds the mechanical seal in place and is mounted to the motor shaft with a single bolt and is keyed in place so it can't slip. And lastly, we've got our impeller options. Typically, you've got 2 or 3 impeller options for each size OverWatch system, and those mount to the impeller hubs with 4 or more hex head screws. Those impellers, if your conditions of service do change, or if you determine that you do need a dip cut impeller instead of the vortex style, they are easily exchangeable, and they can be replaced with just those 4 screws. The motors on these systems have a cast iron body. If for some reason you are in a corrosive environment where you did need stainless steel motors, we do have the option to source those. The overall body of the system is 304 stainless steel. And again, if you do run into a more corrosive application, we've got a 316L stainless steel body available as an option. The standard motors that we use are the IP67 design, which are immersible for short periods of time. We also have additional motors available, whether if you need an FM explosion-proof motor, we've got options there. And we've got CSA motors, which are suitable for use in Canada. Many of those have different IP ratings, and we would make sure to call that out as needed for the different motor approvals.
Thanks, Steve. So the key benefits again of this is you're eliminating a wet well. So you got to think about all the cost savings that this could supply the town and the utility. No vac trucks, no odor suppressant systems since everything is closed loop. But there's also safer working conditions because as we talked about, the hydrogen sulfide is now completely not exposed to the operators and the people working in and around what was a wet well, which we'll call just a pump station for this. The reduced environmental impact, I will show you a great slide of this compared to a traditional wet well or wet pit, dry pit situation. And we'll highlight a lot of the smaller footprint. So if there's any greenfield applications, the OverWatch really shines and can pay for itself right off the bat. Again, this is self-monitoring, so all the telemetry and communications are built into the panel. All the signals can be sent up to whatever SCADA system they have or however they need to be notified. Any of the signals can be sent that they want to monitor. And then again, it's non-clog, so it's going to be really, really good for those retrofit situations if there is a pump station out there that they're having to send work crews out to declog. This thing will basically be passing 1 or 2 wipes at a time instead of passing a bunch of wipes. It's eliminating the fats, oils, and grease layer, and then it's able to react if it does need to react and go into reverse to shred up anything that is in the pump's volute. So you can see this one is actually in a parking garage. So these things can be above grade. It just all depends on where that gravity invert is coming in. It's not ever going to be like a vacuum style pump or a suction lift pump. It's going to have to sit below that gravity invert, but wherever that gravity invert's coming in is where we're mounting right up to it. So you can see their control panel is mounted back there in the background as well, but this is actually in a parking garage too. So this just shows you how this thing works and how you can see that it contains all that influent, and so there's no odors at all, which is great. Reduce environmental impact. Again, everything is 304L stainless steel. Some of the industrial applications we've gotten in are 316 stainless steel, but everything welded is 304L stainless steel. Really, the only cast iron you're going to see is on those casings of the valves in the motor. So it's meant to last. It's meant to combat all that hydrogen sulfide that can come down the network and still last for a long, long time. Um, this is a very powerful slide that I like to highlight. So on the right is the OverWatch direct inline pump system. On the left would be your traditional wet well, where you have a submersible style pump, you have some floats, you have a valve vault off to the right. I think the first thing you will probably notice is that there is no valve vault with the OverWatch. So that excavation point is completely eliminated. All the valves are contained into one. The second thing I think you'll notice is that delta H. So with the Overwatch, we're eliminating, it could be 8, 10, I've seen 15 feet on some applications when you're digging down more with the traditional wet well. So if you think about how much it costs to dig down per foot down into the earth, it can save a lot of money. Where this really, really does well is certain terrains where there's bedrock that is very hard to dig down deep into, and it's very costly to dig down deep as well. And then if you think of any places maybe out by the coast that have like a high water table issue. So that is very, very costly to dig down deep with a lot of the construction that it takes and the time that it takes. There's less static head with this, less construction and excavation. What we really need is only anywhere from about 20 to 24 inches from the center line of the lowest point of gravity invert to the bottom of it. And in this picture too, you can see highlighted is that sump pump that's tied back into that low pressure side too. So this is a good depiction of what you would see with an Overwatch, a nice clean dry environment versus a traditional wet well, and the cost savings and the environmental impact with it. So saving time and money, time always equates to money. So this is meant so you don't have to do a lot of reactive or proactive maintenance. In our IO&M, we have certain proactive maintenance you should do with this, but we've seen that it is very far less than what you have to do with a traditional wet well. You don't have to deal with cleaning out a wet well, breaking up that concrete layer, having to do any of that you typically have to do. This thing is going to be able to detect and tell you what's going on in real time. It's going to be able to provide trends and data to you so you can actually get insights into the system. And then it has different communication protocols built into it. One of the most common protocols we see is the Modbus TCP over IP protocol that is built into this controller with this. And then reduce maintenance. Here's a great picture. So you can see this really highlights this picture in the background, different configurations we can do with this. So if you see coming in from the left side, there's 2 gravity inverts coming in here. So there's sewage or wastewater or stormwater coming in from 2 different points. It's all getting mounted into one central location where the invert of the Overwatch is, and then that is going back out, and this has 2 different discharges. So I think a lot of the slides you have seen have a common discharge, but this shows some of the different configurations that we can do. But again, everything's going to have a lot longer lifespan because it's all 304L stainless steel, and then you don't have that sulfuric acid that's eaten away at any of the concrete or metallic structures. So I'll play a quick video here, give you guys a 2-minute video that basically wraps up what we've been talking about here, and then we'll dive into a couple different slides and get into a couple different case studies.
Industrial Flow Solutions presents OverWatch Direct Inline Pump System, a revolutionary wastewater pump system that eliminates problems associated with traditional wet wells. With an OverWatch system, wastewater does not accumulate in an open pit. The system is designed to lift influent from the point of entry and move it directly to the discharge, thus eliminating unpleasant and hazardous odors, increasing operator safety and minimizing maintenance interventions. The OverWatch smart sensing system adjusts in real time to manage flow and avoid clogs, guaranteeing uninterrupted operation. In the duplex configuration shown, the OverWatch allows for complete redundancy with one pump online while the other pump remains on standby. Both pumps are sized for 100% capacity. When the system detects increased torque due to a clog or rag obstruction, the flow is directed from the online pump to the standby pump. The pump facing the obstruction is reversed, deploying the depth cut impeller shredding blades to clear the blockage. The pump returns to normal operation when acceptable torque is measured. The system ships from the factory pre-configured and tested. Modular construction allows easy installation in new or existing structures with minimal ground excavation or structure modifications. The factory-supplied control panel can be monitored either locally or via the cloud through a connected device.
So that highlights a good 2-minute video. If you need to rewatch this video, it is up on our Industrial Flow Solutions YouTube page. And you'll be able to find it. So I'll kick it back over to Steve to dive into the controls.
So when we supply these OverWatch systems, we are supplying both the pump body and the control system as a complete package. Each of the motors will have its own VFD, and they will be running to match the flow rates that are required. The VFDs will also sense any blockages and allow the reversing of that pump to clear the blockage, whether using a vortex or a dip cut impeller. The standard panel that we offer would just include the VFD keypads as the interface to the drives and the control logic. We also offer an OverWatch Pro control panel, which would include the touchscreen shown in the right-hand side. That touchscreen allows us to use a few different types of VFDs and really control the logic within that touchscreen. All of these panels are built in-house, and we do test every unit with the panel that it goes with to make sure that it is completely functional and ready to operate immediately once it's put out in the field and started up. As Brad mentioned, we do have many different configurations of these OverWatch available. On the left-hand side, we're showing our duplex configuration with the split discharges. This allows us to put knife gate valves on the suction and discharge side of each volute, which gives us the opportunity to completely isolate one side without having to shut down the complete system. Your second pump can continue to operate, and you can isolate the one volute both mechanically and electrically with a shutoff in the control panel. On the right-hand side, we were showing our triplex systems, which can allow higher flow rates and more redundancy compared to the standard duplex system, depending on the application requirements.
Thank you, Steve. So I mentioned the first municipal install was in Sherman, New York. So the chief wastewater operator there is Jay Irwin. They have a very, very small plant down there. I think it's a 0.17 MGD plant. So it's about 7 miles of gravity until it hits the influent pump station. So the only pump station in town, a critical pump station if it goes down. And what they had was the picture on the left. And to kind of picture what was going on there, it was a dry pit, wet pit scenario. They kind of had a bar screen down there, and you can see those pictures. There's kind of rags building up and building up and building up. This is a municipality where there's not a lot of people in the town, and there's one full-time person that works there, Jay, and then they had a part-time person that worked at the wastewater treatment plant. So along with doing all their process tasks that they had to do on a daily basis, they had to worry about this one pump station. And in January 2018, they decided to go with the OverWatch because in their budget, they were having to send quarterly visits from this back truck to avoid some of the downtime. they were having a fog layers that would get so thick that would actually take up the transducer reading and it was causing overflows. But then they also had to do weekly bar screen cleanings that was taking up a bunch of time. So he needed something that could go in there, be a drop-in replacement, and then provide all of the solutions to those issues. So since then, he's been down there only a couple times. He's done barely any maintenance on it. He's had to change out a bearing for the motor. He upgraded his panel a little bit, and that's about the only maintenance that he's really done to this thing. He's completely eliminated having to send out back truck visits to his site, having to go down there and clean out any screens, having to deal with any SSO events. He's completely eliminated all that. So it's able to tell him what's going on in real time with his panel and his telemetry. So he could be sitting at home and logging onto his phone and seeing what actually is going on. And he's able to pull data from it as well. So a great case study. He's had it for 6 years in a municipal application in the States. I'll kick it over to Steve for this one.
This application is another Northeast application in Franklin, Massachusetts. The customer had a pneumatic ejector system that was aging, prone to breakdowns, and they were having trouble getting the parts to perform maintenance on this. One of the most costly aspects of using a pneumatic ejector system is the compressed air required to move the sewage from that system. And it also was unable to handle the new non-woven wipes that are clogging up wastewater systems all over the place. The OverWatch direct inline pump system allowed them to eliminate the compressed air requirement and just operate using electricity on demand as needed to pass the solids through. The installation actually simplified some of the plumbing in that room and allowed for a lot more floor space to simplify the installation overall. And since then, they've reduced maintenance calls and costs and eliminated the clogs from the flushable wipes that we're having there.
So this one is a large municipality in Georgia. It's a really cool one because it's actually inside the fence. So besides just thinking of lift stations, this could be inside the fence applications with this technology. So they actually had, this is a scum pit application where they had secondary clarifiers, and they had a scum pit where they had 16 different clarifiers, and they had 24 AOD pumps that were constantly failing and resulted in a lot of downtime with this. So what they did is they were able to eliminate those 24 AOD pumps, put in 8 different overwatches. So they went from 24 to 8. So a lot less maintenance they have to do. And what this is able to do is it's able to see that scum layer off the secondary clarifier. It's able to handle that debris. It has a solenoid valve on it that it's able to feed it some water as well. And then it's sending it down to wherever it's going next in the process. They've had this one installed for about 2 years, but maybe 3 years or so, but it's able to show the capabilities of this system inside the fence. So my email is below, Steve's email is below. There's our general number and our general sales email. We do have different trailers that are out on the road in the United States. If you guys want to get on the schedule to maybe show your municipality or show the consulting firm you work at, please feel free to reach out to us. If you want to see maybe one of those 250 plus installs in person, one that's close by, and speak to some people that as a reference that have had these installed, please reach out to Steve or I, and we can definitely do that. If you want to see a static unit of it, like the picture on the right, there's a demo pump there as well. But feel free to definitely reach out to us, and we can talk to you more about specific applications or do different lunch and learns for you guys. So there's a poll question I think Joy just put up, and you could just answer that question, and we'll give it about 30 more seconds here, and then I'll kick it over to you, Joy, to ask the questions for Steve and I.
Absolutely. I will actually just leave this poll going for people to answer as we are answering questions. So I have quite a few questions coming in. Again, we encourage you to reach out to Brad and Steve directly through the email addresses if we don't get to your questions. But let's start with this first one. What is the biggest size unit that you currently have done in the United States?
Yeah, so we've done a couple units we go up to about 200 horsepower for the biggest, or for our biggest horsepower motor, and then 5,000 gallons per minute just per one side and one volute, and then 400 feet ahead. But the biggest one in the States that we've done so far is the duty point is a little over 3,000 gallons per minute at 204 feet ahead. So I think it's 3,100 gallons per minute at 204 feet ahead. A large master station down there in the southeast for a municipality. But overseas, they have some even bigger that they've done over there in France.
Great, thank you. And then how much room do you need for an average installation?
So for our typical installations, usually the smallest we do, we have a minimum installation sheet that we supply that shows all the valves plumbed up and how it would align. And it's about 6 feet in diameter. I've seen them go in about 48-inch basins for some of the smaller ones we do as well. So it all depends on the size, but the most popular body size we do for about 40 or 50 horsepower and down will fit in a 6-foot basin.
Thank you. And then can you share what spare parts are recommended?
Yeah, I'll take this one, Brad. One of the common spare parts that we offer with the OverWatch is a completely assembled motor block. That would be everything from the motor down to the impeller. And that allows you to remove the failed motor, install the replacement, get yourself back up and running, typically within less than an hour. And then you can take the failed motor assembly back to the shop, repair it as time permits, and know that you're running full speed with redundancy in the application.
Thank you both. Brad and Steve, I'm going to pass it back to you. We have less than a minute left. Pass it back to you for some final remarks before I close this out.
Yeah, so I will say I see some questions we did not get a chance to get to. Steve and I will reach out to you guys back in an email individually and get these questions answered. But yeah, feel free to go to our website, flowsolutions.com, and if you look up Overwatch on there, there's sets of curves, different technical data sheets that you can pull as well. But definitely feel free to reach out to us if you want to get more technical information or talk about applications or maybe see different designs that other people have done across the country with this technology. You got anything,
Yeah.
Steve?
I'd like to thank everybody for taking the time to join us today. As Brad mentioned, reach out to us with any questions you might have.
Thank you, everyone.